Hi guys, I'm hoping that you are having a good day. So for today, before we proceed to our math lesson, please don't forget to hit the subscribe button and the notification bell for more videos. Alright, let's continue. Now, we're going to talk about operations on radicals. So we're done with the roots of a number and radical expressions. Now, let's apply those things in performing the operations on radicals. So, as a beginning activity, let us answer this. What is the value of my radical? Instruction is, give the value of each radical given and write the answer on the space provided. This is in relation with the previous table that we have answered in the previous video. So number 1, let's have square root of 64. So as you can see, 64 is a perfect square. Therefore, if we will be subtracting the square root of 64, it is 8. Next, let's have cube root of 8. 8 is a perfect cube number. So therefore, again, if we will be constructing the cube root of 8, so we will be getting 2. Next, we have square root of 169. And 169 is still a perfect square just like number 1. So if we will be extracting the root of square root of 169, we will be getting 13. Next, number 4, cube root of 64. So for cube root of 64, again, 64 is also a perfect cube number just like it's also a perfect square. So therefore, if we will be extracting the cube root of 64, we will be getting 4. Then lastly, we have number 5, square root of 324. And 324 is a perfect square number. So if we will be extracting the root of this, we will be getting 18. So guys, my advice is that you have to be familiar with the perfect square and then perfect cube numbers, because these are the common numbers that are that you are going to encounter in performing the operations on radicals. So let's go. Now let's start first with adding and subtracting similar radicals. You have to take note that only similar radicals can be combined. Again, only similar radicals can be combined. So how are we going to know now if radicals are similar? So the first thing is that let's have the following examples. So the first thing is we have 2 square root of 2 and 5 square root of 2. So as you can see, I have highlighted using a red pen the characters or the radicals. So it means that we can say that radicals are similar if their radicands and indices are the same. Alright? So that's the thing that you're going to consider. So you do not care about its coefficient. Okay, so 2 and 5 here are the coefficients of the radicals. So your concern is that the indices and the radicands must be the same for you to be able to find out if it is similar or not. If the radicals are similar or not. Alright? Now, let's have the second one. Square root of 3xy and 18x cubed square root of 3xy. So as you can see, still, the radicands are similar and the indices are also similar. Therefore, we call them similar radicals. Again, we do not care about the coefficients. Okay, just like here, the coefficient of the first radical is 1 and the other one is 18x cubed. So what we care about is the radical. So if the radicals are similar, therefore we call them similar radicals, of course. Next, we have 2x squared cube root of 4y squared and negative 9x squared y squared cube root of 4y squared. Again, they are similar because the radicals are similar. So we have cube root of 4y squared and cube root of 4y squared as well in the second radical expression. Then lastly, we have 2 square root of 3 over 7 and 5 square root of 3 over 3. 5 square root of 3 over 3. So as you can see, the coefficients are fractions. All right, so we have 2 over 7 and 5 over 3. Again, we just have to look at the radicals if they are the same. Therefore, they are what we call similar radicals. Now, let us now add and subtract similar radicals. First thing is, let's have number 1. We have to combine into a single radical. So for letter A, we have 4 square root of 5 plus 3 square root of 5. So as you can see, they are what we call similar radicals because they both have a radical of square root of 5. So what we have to do is just simply add the coefficients. 4 plus 3 square root of 5. Then 4 plus 3 is 7 square root of 5. Therefore, this will be the sum of 4 square root of 5 plus 3 square root of 5. Next, let's have letter B. 3 fourth root of 2 minus 6 fourth root of 2. They are similar radicals because they both have a radical of 4 square root of 2. So what we have to do is to subtract the coefficients. 3 minus 6 fourth root of 2. And 3 minus 6 is negative 3. Then put the radical fourth root of 2. Therefore, this will be your difference or the answer. Next, letter C. We have 5 cube root of 3x plus cube root of 3x. So, they are still similar radicals because of the radical 3 or cube root of 3x. So, therefore, we just have to combine 5 plus 1 cube root of 3x. Alright? So, here, okay, if they are not similar, of course, you cannot combine. So, in the next part, okay, so we're going to encounter the similar radicals and how are we going to combine or subtract them. Then letter D, no, we have to finalize this. 5 plus 1 is 6 cube root of 3x. Then lastly, letter D, 3x squared square root of xy minus 2x square root of xy. They are similar radicals because of square root of xy. So therefore, we are going to subtract 3x squared and 2x square root of xy. But the problem here is that the coefficients are dissimilar. So therefore, if we're going to apply the principles in algebra, we cannot combine them. So therefore, this will serve as your final answer. Okay? So same thing with the coefficients. If the coefficients are not similar, of course, you cannot combine or you cannot add or subtract them. Alright? That's how you're going to add and subtract similar radicals. Now let's proceed to this one. Adding and subtracting dissimilar radicals. So radicals that are not similar or dissimilar radicals may become similar when simplified. Remember in our previous lesson, we've talked about on how we can actually simplify radical expressions. So we're going to apply it here. Okay, guys? Now, let's continue. Make each pair of radical expressions similar. So how are we going to make them similar? Of course, we have to simplify. We have to apply the rules that we've studied from the previous lesson here. We have the product rule for radicals and quotient rule for radicals so that we can simplify. Alright, so let's start with letter A, square root of 8 and square root of 50. So let's start first simplifying square root of 8. So 8 is not a perfect square. So in our previous lesson, if it's not a perfect square, we have to factor the radicand so that, okay, we can get one perfect square and its factor. So we have to find the two factors wherein one of the factors is a perfect square. So square root of 8, and if we're going to factor 8, alright, so just look at the table of perfect squares and perfect cube. Just divide 8 to the perfect square numbers, and then once you got an exact answer, therefore those are two factors. Right, the perfect square and the result or the quotient. So square root of 8. The factors of square root of 8 are 4 and 2. So as you can see, 4 times 2 is 8 and 4 is a perfect square and 2 is not. So therefore, we can extract the root of 4. Square root of 4 is 2 square root of 2. Therefore, this is the simplified form. Now, let's proceed to square root of 50. So for square root of 50, 50 is not a perfect square. So all we need to do is to factor 50, wherein one of the factors is a perfect square. And the factors of 50 are 25 and 2. Then 25 is a perfect square, therefore square root of 25 is 5 square root of 2. So as you can see, here they are not similar, but after we simplified them, as you can see, they both have the same radical. Alright, so they both have square root of 2. So therefore, they are similar, and if you're going to add or subtract them, then you can do it because they are already similar. Next, letter B. We have 3 square root of 12 minus 2 square root of 48. So as you can see, they are still not similar because of the radicals square root of 12 and square root of 48. So therefore, we have to simplify the two radicals. First is, let's start with 3 square root of 12. So, same thing, 12 is not a perfect square, so therefore, we have to factor 12 wherein one of its factors is a perfect square. So, the factors of 12 are 4 and 3. And 4 is a perfect square. So, square root of 4 is 2. 3 times 2 square root of 3. Then 3 times 2 is 6 square root of 3. Next, we have negative 2 square root of 48. Alright, so we're going to factor 48 so that we can get one perfect square. So negative 2 square root of, so what are the two factors of 48? So the two factors of 48 are 16 and 3. And 16 is a perfect square. So therefore, square root of 16 is 4 square root of 3. Alright? Then negative 2 times 4 is negative 8 square root of 3. Therefore, this is the simplified form of the radical negative 2 square root of 48. So they are now similar radicals. We have 6 square root of 3 and negative 8 square root of 3. Alright? Next, letter C, we have negative square root of 3xy minus 6x squared square root of 27x cubed y. So as you can see, class or guys, 3xy or square root of 3xy is already simplified. So therefore, we cannot anymore simplify this, of course. Now, let's proceed to negative 6x squared square root of 27x cubed y. Alright, so the radicand has variables. So therefore, of course, we have to also make the variables perfect square if possible. Alright, now, next, negative 6x squared, then let's have the factors of 27, 9, and 3, wherein 9 is a perfect square. Then x cubed, remember if the index is 2 and then we have the exponent 3, 3 is not divisible by 2. So therefore, we have to find way to make it's divisible. Let us factor x cubed. We have x squared times x times y. So if we are going to apply multiplication law of exponents, x squared times x is still x cubed. Alright, so we can now move out x squared. So let us extract the roots. Negative 6x squared square root of 9 is 3. Square root of x squared is x. Then the radical 3xy or square root of 3xy. Now we will combine. Negative 6x squared times 3 times x. So negative 6 times 3 is negative 18 and x squared times x is x cubed. Then copy the radical square root of 3xy. So therefore, this is the simplified form. So as you can see, they both have a radical now of 3 square root of 3xy. So therefore, they are now similar radicals. Alright, so let's proceed. Letter D. Make each pair again. So we have letter D, cube root of 32x raised to the power of 6y squared and negative 3x squared y cube root of 108y raised to the 5th power. Alright, so how are we going to make them similar? Okay, so let's start with the first one. Cube root of 32x raised to the 6th power y squared. So, first, we will be factoring 32. So, we have to factor 32 wherein one of the factors is a perfect cube. So, the factors of 32 are 16 is a perfect cube times 2 times x raised to the 6th power. So, x raised to the 6th power is the exponent is divisible by 3. Therefore, it's a perfect cube. Y squared, we cannot actually move it out, the y squared, because it's not a perfect cube. Next, cube root of 16 is 4. Then cube root of x raised to the 6th power is x square. Okay, and then square root of 2y square. Or rather, cube root of 2y squared. Sorry for that. I apologize. Next, let's have the second one. negative 3x squared y cube root of 108 y raised to the 5th power. Alright, so let's copy it. Negative 3x squared y cube root of 108 y raised to the 5th power. Next is, let's factor negative 3x squared y. Then, so let's factor 108, wherein one of the factors is a perfect cube. So the factors of 108 are 27 and 4. Then y raised to the 5th power, we have to factor it so that the exponent will be divisible by 3. So it's now y raised to the 3rd power y squared. Then the next thing is, let's simplify. Negative 3x squared y, then cube root of 27 and cube root of y cube. Alright, next. Cube root of 27 is 3. Then cube root of y cube is y. Then cube root of 4y squared. Then, let us multiply. Negative 3 times 3 is negative 9. X squared, then y times y is y squared. Cube root of 4y squared. So as you can see, even though after we simplified them, they are still not similar radicals. So therefore, we cannot actually combine them. So even if after simplifying, they are still not similar or dissimilar radicals, we cannot do anything about it anymore. Okay, so therefore, you cannot add or subtract them. That's it. Next, let's have letter E. Square root of 12 over 49 and square root of 75 over 3. Let's start first with the square root of 12 over 49. So we will be applying quotient rule for radicals. This will become square root of 12 over square root of 49. Square root of 12, let's factor it. We have 4 times 3. Then square root of 49 is a perfect square number, so therefore it's 7. Then square root of 4 is 2 square root of 3 over 7. This is now simplified. Alright? Next, square root of 75 over 3. So, we will be factoring 75 wherein one of its factors is a perfect square. So, we have 25 and 3 over 3. Then, square root of 25 is 5 square root of 3 over 3. Therefore, this is already the simplified form. So, as you can see, they both have a radical of square root of 3. Therefore, they are what we call similar radicals. Now, let's apply those things here in these examples. Let's have letter A. So the instruction is that simplify the radicals in each expression, then combine similar terms. For letter A, we have square root of 32 plus square root of 18 minus square root of 50. So of course, we have to factor so that we can get perfect squares. The index is 2 here. Alright, so the factors of 32 are 16 and 2. Factors of 18 are 9 and 2. Then factors of 50 are 25 and 2. Now, we will be extracting the roots of the perfect squares. So square root of 16 is 4 square root of 2 plus square root of 9 is 3 square root of 2 minus square root of 25 is 5 square root of 2. Then as you can see, they are already similar radicals. Therefore, we can combine the coefficients. We have 4 plus 3 minus 5 square root of 2. So 4 plus 3 is 7 minus 5 is 2 square root of 2. This will be now your final answer. Alright? So let's have letter B. Square root of 4ab cube minus square root of 16a cube b minus square root of ab. So as you can see, square root of ab is already simplified. So therefore, we just have to simplify the first two radicals. Alright? So, square root of 4 is already 2. Square root of a, then let's factor b cube. It will become b squared b. Minus square root of 16 is already 4. Square root of a square a b minus square root of ab. Next thing is 2. Then let's move out square root of b square, which is b. Square root of ab minus 4. Then let's extract the root of a square. It will become a. Square root of ab minus square root of AB. So as you can see, there are already similar radicals, therefore we can combine, or rather we can subtract the coefficients. Now we are going to have 2b minus 4a minus 1 square root of AB. And as you can see, so these are the similar terms, so therefore we cannot actually subtract them. This is already your final answer. Now let's have letter C. Cube root of 375 minus cube root of 81 minus cube root of 24. Let us simplify so that we can actually get the final answer, of course. But before that, we have to actually factor the radicands. Alright, so that we can get one perfect cube for each. Okay, so let's start with the first one. Cube root of, so what are the two factors of 375 wherein 1 is a perfect cube? We have 125 times 3 minus cube root of factors of 81 wherein 1 is a perfect cube. We have 27 and 3. Then factors of 24 wherein 1 is a perfect cube. We have 8 and 3. Then simplify. Cube root of 125 is 5. Cube root of 3 minus cube root of 27 is 3. Cube root of 3. Then cube root of 8 is 2 cube root of 3. So as you can see, they are already similar, therefore we can combine. 5 minus 3 minus 2 cube root of 3. So 5 minus 3 is 2, minus 2 is 0, of course. This will be your final answer. Okay? Next, let's proceed. Letter D. X cube root of 16 minus 2 cube root of 54x cube plus 3 cube root of 192. Same thing. We will be factoring. So x cube root of 2 factors of 16 wherein 1 is a perfect cube. We have 8 and 2. Minus 2 cube root of factors of 54. We have 27 and 2 x cube. So x cube is a perfect cube. Plus cube root of 192, or the factors of 192 are 64 and 3. Then of course the next thing is we will simplify. X cube root of 8 is 2 cube root of 2. Or simply we can write it as 2x. Okay? We can write it as 2x. Minus 2 cube root of 27 is 3. This will be 2 times 3. Then cube root of x cube is x cube root of 2 plus cube root of 64 is, of course, 4 cube root of 3. Next, simplify. 2x cube root of 2 minus 2 times 3 is 6x cube root of 2 plus 4 cube root of 3. We will now combine similar terms. Okay, so only 2 of the radicals are similar because they both have cube root of 2, but the other one is cube root of 3. So therefore, we cannot actually combine it to the third one. Right? So we have 2x minus 6x cube root of 2 plus 4 cube root of 3. So 2x minus 6x is negative 4x cube root of 2 plus 4 cube root of 3. Alright? Then, that will serve as our final answer. Next, we have cube root of x cube over 8 minus cube root of 27x over 8. So the next thing is, of course, quotient rule. We have cube root of x cube over cube root of 8 minus cube root of 27x over cube root of 8. Alright, so let's factor the numerator of the first one. We have cube root of x squared times x over cube root of 4 times 2 minus cube root of it's a square root, sorry. We have square root of 27x, so this will be 9 times 3x over square root of 4 times 2. Now let's simplify. Square root of x squared is x square root of x over square root of 4 is 2 square root of 2. Next, we have square root of 9 is 3 square root of 3x over 2 square root of 2. So as you can see, they are similar fractions because they have the same denominator. So therefore, we can just simply combine them in a single fraction, but the numerators are not similar. Therefore, we're going to have x square root of x minus 3 square root of 3x. Alright, so we cannot do anything about this, so that's why this will serve as your final answer. That's how you're going to add and subtract dissimilar fractions. Rather, dissimilar radicals. Sorry for that. Next, let's have multiplying radicals. The main tool in multiplying radicals with the same index is the product rule for radicals that we have discussed in the previous video. Alright? Now, let's have the example 4. Give the product. So, by applying product rule, of course, square root of 7 times square root of 3 is square root of 7 times 3. And 7 times 3 is 21. So, therefore, our answer here is square root of 21. We cannot anymore factor 21 other than 1 in itself. Alright? So, therefore, this will serve as your final product or answer. Let's have letter B. Square root of 2x times square root of 18x cubed. Alright? So here, in multiplying, you don't need, okay, to make the radicals similar. Just simply multiply them directly. Okay? So here we have square root of 2x. It's 2 times 18 and x times x cubed. Then 2 times 18 is 36. Then addition, multiplication law of exponents, x times x cubed is x raised to the 4th power. Then square root of 36 is 6 and square root of x raised to the 4th power is x squared. Therefore, this is your final answer. Next, letter C. 4th root of 2a raised to the 5th power b squared times 4th root of 8a cubed b. Alright? So the first thing is, of course, we have to factor the radicals. No, I'm sorry, we don't need to factor. We can actually directly multiply them. So we have 4th root of 2 times 8, then a raised to the 5th power times a cubed, then b squared times b. Or we can write this as 4th root of 2 times 8 is 16. Then multiplication law, this will become a raised to the power of 5 plus 3. Then b raised to the power 2 plus 1 because b has exponent of 2 and the other has 1. Then 4th root of 16 a raised to the 8th power b raised to the 3rd or cube. Then the next thing is we can now simplify this. Alright? So the answer that we're going to get, 4th root of 16 is, so you can actually calculate it using your calculator, of course. 4th root of 16, you will be getting 2. Then a raised to the 8th power is a square. Of course, 8 divided by 4 is 2. Then we can only move out 16 and a raised to the 8th power. Okay? And then, of course, we have 4th root of b cubed. So this will serve as your final answer. So we also need to apply the law or multiplication law of exponents other than the product rule. Okay? Next, multiplying radicals again. In multiplying a binomial, trinomial, or any polynomial containing more than 3 radicals by a monomial radical, the distributive property of multiplication is used. How is that? Alright, so in the previous examples, we're multiplying monomial to monomial. This time, we're going to multiply a monomial to binomial, trinomial, or any polynomial. Alright, so let's start with A. With A, we have the monomial negative square root of 3 times square root of 6 minus 2 square root of 15. We will be applying distributive property of multiplication here. So we will multiply the monomial outside to the terms inside the grouping symbol. Alright, so negative square root of, so the first one, square root of 3, negative square root of 3 times square root of 6 is 3 times 6. Then negative square root of 3 times negative 2 square root of 15 is positive 2 square root of 3 times 15. Then let us simplify this. Alright, so this will become negative square root of 18, while this one is 2 square root of 45. Then the next thing is negative square root of 18 factor 9 and 2. Factors 9 and 2. Plus 2 square root of 45. The factors of 45 are 9 and 5. Then we can already simplify this. Negative square root of 9, or square root of 9 is negative 3 square root of 2 plus 2 times square root of 9 is 3 square root of 5. Negative 3 square root of 2, 2 times 3 is 6 square root of 5. So as you can see, excuse me, they are dissimilar radicals. Therefore, we cannot anymore simplify them. That's why this will serve as your final answer for letter A. Negative 3 square root of 2 plus 6 is square root of 5. Next, letter B, we have 3x cube root of 9x, the monomial, times 4 cube root of 6x squared minus 4 cube root of 9x squared. So we will just be distributing. Alright. So 3x times 4 is 12x. Then cube root of, so 9 times 6, we just need to multiply 9 times 6, we will be getting 54. Then x times x squared is x cubed minus, okay, 3x times negative 4 is negative 12x. Then cube root of 9 times 9 is 81. Then x times x squared is x cubed. Then of course, we will be simplifying the radicals. Alright, so 12x cube root of 54. Two factors of 54 are 27 and 2, wherein 27 is a perfect cube. X cubed minus 12x cube root of, factors of 81 are 27 and 3 x cubed. Then we can already simplify the radicals. 12x, then we will be moving up, moving out cube root of 27, we will be getting 3. Then cube root of x cubed is x, cube root of 2 minus 12x times cube root of 27 is 3. Then cube root of x cubed is x, cube root of 3. Then 12 times 3 is 36 x squared. X times x is x squared, cube root of 2. Then negative 12x times 3x is negative 36x squared. So it's 36x squared. (36x squared) cube root of 3. Now, this will serve as your final answer. This is already accepted because the radicals are not similar or dissimilar. But we can factor out 36x squared. So it is now 36x squared times cube root of 2 minus cube root of 3. So either of the two is correct. But this one, the first one, is the simplified and the other one is the factored form. Okay, so either of the two is correct. Let's have letter C. Square root of x times square root of x plus x square root of y minus square root of xy. So, we will be distributing the monomial to the trinomial. Alright? Square root of x times square root of x is square root of x squared plus square root of x times x square root of y is x square root of xy. Then, square root of x times negative square root of xy is negative x squared y. Square root of xy is x plus x square root of xy minus x squared, or rather square root of x squared is x, square root of y. Then look if there are still similar radicals. If not, that will serve as your final answer. So in this case, okay, so this is accepted as the final answer, or you can factor out x because it's a common factor. It's x times 1 plus square root of xy minus square root of y. So either of the two is correct. So the first is simplified, the other one is factored. Next, find the product. So in this case, we are multiplying two binomials. So the famous thing that we can apply here is the FOIL method. So for the FOIL method, of course, okay, we will be multiplying the first terms. Square root of 2 times square root of 2 is square root of 4. Outer terms, square root of 2 times negative square root of 3 is negative square root of 6. Inner terms, square root of 3 times square root of 2 is square root of 6. And then last terms, we have square root of 3 times negative square root of 3 is negative square root of 9. So, as you can see, negative square root of 6 plus square root of 6 are opposite radicals. So, therefore, we can just subtract them to get 0. Then, square root of 4 is 2. Then, negative square root of 9 is negative 3. 2 minus 3 is negative 1. This will serve as your final answer. Then, for letter B, we have square root of 6 minus square root of 2 square. We can just make this 2 or expand them. We will be having square root of 6 minus square root of 2 times square root of 6 minus square root of 2. Apply the FOIL method. First term, square root of 6 times square root of 6 is square root of 36. Outer terms, square root of 6 times negative square root of 2 is negative square root of 12. Inner terms, negative square root of 2 times square root of 6, we have negative square root of 12. Last terms, negative square root of 2 times negative square root of 2 is positive square root of 4. Then simplify, square root of 36 is 6. Negative square root of 12 minus square root of 12 is negative 2 square root of 12. Then square root of 4 is 2. 6, we can only combine 6 and 2 here. So 6 plus 2 is 8, negative 2 square root of 12. So this will serve as your final answer. That's how you're going to multiply radicals. Next, let's proceed in dividing radicals. The quotient rule for radicals and the division law of exponents show how to get the quotient of radicals of the same index. Alright? So, example 6, give the quotient. So, square root of 35 divided by square root of 7. We can write this as square root of 35 over square root of 7. Then, applying the quotient rule, it is square root of 35 over 7. 35 divided by 7 is 5. So, the answer is square root of 5. Next, here, we can write this as square root of 75 x raised to the 8th power y raised to the 4th power over square root of 3x raised to the 5th power y raised to the 4th power. Quotient rule, this will become 75 x raised to the 8th power y raised to the 4th power over 3x raised to the 5th power y raised to the 4th power. Then, simplifies, applying the division law of exponents. 75 divided by 3 is 25. Then, division law of exponent, just keep and subtract the exponents. Unlike multiplication law, you need to add, but this time, you need to subtract. It is x raised to the power of 8 minus 5. Then, y raised to the power of 4 minus 4. So, this will become y raised to the 0 power, or simply 1. 0 law of exponents, whatever number except 0 when you raise to 0, the answer is always 1. Alright, so let us now simplify. Square root of 25 is 5. Square root of x, 8 minus 5 is 3. Then we can still factor 5 square root of x square x, or simply 5x square root of x, because x squared is a perfect square. This will serve as your final answer. 5x square root of x. Next, letter C. 4th root of 35x raised to the 5th power divided by 4th root of 7. Alright, so quotient rule, it is 4th root of 35x raised to the 5th power over 4th root of 7. Next, okay, we can actually apply quotient rule again. So, 4th root of 35x raised to the 5th power over 7. Then, 35 divided by 7 is, of course, 5. So, this will become 4th root of 5x raised to the 5th power. Then we can factor x raised to the 5th power. It will become 5x raised to the 4th power x. So we can now extract the 4th root of x raised to the 4th power. It is simply x 4th root of 5x. This will serve as your final answer for letter C. Next, D. Square root of 8 plus square root of 24 divided by 2. So we can write this as square root of 8 plus square root of 24 over square root of 2. Then next thing is we can divide one at a time. So square root of 8 divided by square root of 2 is just square root of 4. Then square root of 24 divided by square root of 2 is square root of 12. Square root of 4 is 2 plus square root of 12 factors of 12, we have 4 times 3. 2 plus square root of 4 is 2 square root of 3. So as you can see, you cannot combine 2 plus 2 square root of 3 because 2 has no radical. It's a whole number. Therefore, this will serve as your final answer. Next, rationalizing the denominator. So when are we going to apply rationalizing the denominator? So you're going to apply this one if and only if there's a denominator of radical. So if there's a radical denominator, therefore we have to omit the radical denominator because that is called irrational number. How are you going to make it rational? We have to apply rationalizing the denominator to remove the radical denominator. So division of a radical by another radical may result in a rational expression that contains a radical in the denominator. Such expression is not considered simplified since the denominator is not rational. To eliminate the radical in the denominator of a rational expression, a process called rationalizing the denominator is needed. Alright? So, let's have example number 7. We have square root of 3. For letter A, we have square root of 3 over square root of 2. So, as you can see, the denominator has a radical. Therefore, we have to omit this. We have to form another fraction wherein it is equivalent to 1. When we say equivalent 1, when you divide them, they are the same. Therefore, you will get 1. Square root of 2. The index is 2 and the exponent of 2 is 1. So, we have to complete the index of 2. Okay, how many more do we need? As the exponent of 2, we need another 1. So, therefore, we can complete as by applying square root of 2 over square root of 2. Remember that, okay, this must be equal to 1, this fraction, so that you will not change the value of the original expression. Alright, in that case, we can already simplify this and remove the radical denominator. Square root of 3 times square root of 2 is square root of 6 over square root of 2 times square root of 2 is square root of 4. Square root of 6 cannot be simplified anymore. But we can simplify square root of 4. Square root of 4 is already 2. Therefore, this will serve as your final answer. It's now the rationalized expression. Alright, so as you can see, from having a denominator of radical, okay, we are able to remove the radical denominator by applying the process of rationalizing the denominator. For letter B, we have cube root of 7 over 2x. Alright? So, of course, for the meantime, we have to apply quotient rule here. This will become cube root of 7 over cube root of 2x. So, the index of the radical denominator is 3. And then, take note that 2 has an exponent of 1 and x has an exponent of 1. So, all we need to do is to complete, okay, is to make the exponents of 2 and x 3. How many more do we need? We need 2 more exponents for each. Alright, so we can have cube root of 2 square x square to complete the index of 3. Alright, so this will serve as our fraction that we will multiply. Cube root of 2 square x square over cube root of 2 square x square. Then the next thing is, of course, we have to multiply. 2 square here is 4, right? Next, so cube root of 7 times cube root of 4x squared. 7 times 4 is cube root of 28. So let's erase this. The index must be on the upper left of the radical. So cube root of 28 x squared over, okay, so this will become now cube root of 2 cube x cubed. So we can now extract both. Right? So 28, we cannot actually have a factor of 28 wherein 1 is a perfect cube. So therefore it will remain, and then even x squared. So it is now cube root of 28 x squared over cube root of 2 cube x cubed is just 2x. So this will serve as your final answer, or the rationalized expression. It's now cube root of 28x squared over 2x. Next, square root of 1 over 5. So we can apply quotient rule, square root of 1 over square root of 5. Then square root of 1 is 1, then over square root of 5. Rationalize, complete the index of 2. So we're going to have square root of 5 over square root of 5. 1 times square root of 5 is square root of 5 over square root of 5 times square root of 5 is square root of 25. The square root of 5 over square root of 25 is 5. So therefore, this will be your final answer. Next, rationalize the denominator. So as you can see, both examples has a denominator of binomial with the radical. So here we will be applying the sum and difference of binomials, or the special product. So remember, for the sum and difference, if we have a plus b times a minus b, so we will be having an answer of a squared minus b squared. This is the thing that we're going to apply here. Alright? But on the numerator, of course, we have to apply the FOIL method. Here, so this is difference, so therefore we need the sum. Okay, so we're going to have 5 plus square root of 5 over 5 plus square root of 5. So let's have first the numerator, apply the FOIL method. 2 times 5 is 10. Outer terms, 2 times square root of 5 is 2 square root of 5. Inner terms, square root of 5 times 5 is 5 square root of 5. Last terms, okay, so square root of 5 times square root of 5 is square root of 25. Over sum and difference rule, square the first term, 5 square minus square root of 5 square. Alright, so let's simplify the numerator. So 10, 2 square root of 5 plus 5 square root of 5 is 7 square root of 5 plus square root of 25 is 5 over square root of 5 is 25 minus square root of 5 square. Square root of 5 square is just simply 5 if you will be extracting the root. 10 plus 5 is 15 plus 7 is square root of 5. Then the next thing is we will be simplifying the denominator. We have 25 minus 5, or simply 20. Alright, so since we cannot anymore simplify this and then we are able to omit the radical denominator, this will serve as your final answer. Next, we have 2 square root of x minus 3 square root of y over 3 square root of x plus 2 square root of y. Since this is already the sum, we need the difference. So 3 square root of x minus 2 square root of y over 3 square root of x minus 2 square root of y. In the numerator, we will be applying FOIL method. 2 square root of x times 3 square root of x is 6 square root of x square. Outer terms, we have 2 square root of x times negative 2 square root of y is negative 4 square root of xy. Inner terms, we have negative 3 square root of y times 3 square root of x, it's negative 9 square root of xy. Then last terms, we have negative 3 square root of y times negative 2 square root of y is positive 6 square root of y square. Over square the first and last. So 3 square root of x square plus 2 square root of y square. So let us simplify this one. Combine the similar terms above. So 6 square root of x square is just simply 6x. Negative 4 square root of xy minus 9 square root of xy is negative 13 x square root of xy. Then 6 square root of y square is simply 6y over square of 3 is 9, square root of x is x, then square of 2 is 2, square root of y is y. Then we cannot anymore combine some other terms in this example, so therefore this will serve as your final answer. That's how you're going to rationalize a radical denominator. Next, let's have this one. Let us apply the rationalizing the denominator here, and this will serve as our last example for this video. So for letter A, we have 3 square root of 8 minus square root of 12. So we can rewrite this as 3 square root of 8 minus square root of 12 over square root of 6. Alright, next thing is we can already actually simplify this, okay, by getting the fraction square root of 6 over square root of 6. But remember that we have to distribute square root of 6 to the binomial in the numerator. So 3 square root of 8 times square root of 6 is what? It is 3 square root of 48. Then negative square root of 12 times square root of 6 is negative square root of 72. Then over square root of 6 times square root of 6 is square root of 36. Then 3 square root of 48, let us factor. 3 square root of, what are the two factors of 48 wherein one is a perfect square? We have 16 and 3. Then square root of 72, we have 36 and 2 over square root of 36, which is 6. Now let us simplify. Square root of 16 is 4 times 3. Square root of 3. Square root of 36 is 6. Square root of 2 over 6. Then 3 times 4 is 12. Square root of 3 minus 6 square root of 2 over 6. As you can see, 12 and negative 6 above are divisible by 6. So therefore, we can simplify. 12 divided by 6 is 2 square root of 3. Then negative 6 divided by 6 is negative 1 square root of 2. So this will serve as your final answer. Now let's have letter B. 2 square root of 5 minus 3 divided by 3 minus 2 square root of 2. So the next thing is, okay, we can rewrite this as 2 square root of 5 minus 3 over 3 minus 2 square root of 2 times, this is difference, so we need the sum. So 3 plus 2 square root of 2 over 3 plus 2 square root of 2. Simplify, FOIL method. First terms, so it's 2 square root of 5 times 3 is 6 square root of 5. Then outer terms, we have 2 square root of 5 times 2 square root of 2 is 4 square root of 10. Inner terms, 3 times 3 is 9. Then last terms, negative 3 times 3 for the inner term is negative 9. Then last terms, negative 3 times 2 square root of 2 is negative 6 square root of 2. Then the next thing, let us simplify the denominator. We have the square of 3 minus the square of 2 square root of 2. Next, 6 square root of 5. So let's see which are the terms that we can combine on the denominator. So based on my observation, okay, there are no terms that we can combine on the numerator. So therefore, we can copy them directly. 6 square root of 5 plus 4 square root of 10 minus 9 minus 6 square root of 2 over 3 square is 9, and then minus 2 square is 4 times square root of 2 is square root of 2 square is 2. Then we have 6 square root of 5 plus 4 square root of 10 minus 9 minus 6 square root of 2 over 9 minus 4 times 2, or 9 minus 8 is just simply 1. Therefore, our final answer here is 6 square root of 5 plus 4 square root of 10 minus 9 minus 6 square root of 2. This will serve as my final answer. So those are the things that you're going to remember in performing the operations on radicals. So if you do have questions and clarifications, or if you encountered some errors in the discussion, okay, you can actually comment down your suggestion, your question, and your clarification, or you can just simply directly message me. Alright, so for my students, you will be doing the activity that I will be posting in your class. Thank you so much for being with me in this video, and then please don't forget to hit the subscribe button and the notification bell for more videos. Thank you so much.